Hello everyone and welcome back to the channel. In today's video, we are going to explore how to build Bizagi Custom Connector using native built-in Node.js HTTPS module without relying on any external libraries. Many of you probably know Axios. It's popular and very powerful Node.js library which can be used for API calls. However, in this video, I want to show you an alternative approach that doesn't require any third-party dependencies. This can be especially useful in enterprise environment where simplicity, security, and package size really matters. Let's go step by step and start with basic error handling. Before building any business logic inside connector action invoke function, I always recommend wrapping your implementation in try-catch statement. This ensures that if anything goes wrong, such as simple typo or runtime error, the connector will always return proper error back to the Bizagi engine. That error can then be handled gracefully in your process. Without try-catch statement, connector might fail silently and return unclear error. With proper error handling in place, you will get clean, readable error messages. And if you include stack trace attribute, you will get full details of the error and exact place in the code where error occurred. This makes troubleshooting much faster. To make connector code logical, after try-catch statement, I always define all the global parameters. These usually include values such as host, timeout, retry limits, which are defined in the connector system configuration. Keep in mind that all system configuration values are received as strings. So when needed, you must explicitly parse them into integers or any other data types. After that, I am extracting any authentication-related parameters as API key or token in this example. Token we will receive not from the system configuration, but from the auth.js implementation. Next, I'm defining all the input parameters which will come from the Bizagi process. I always recommend passing case number as an input. This is extremely helpful for tracing API calls later. Once you have all the inputs defined, I highly recommend also to use Bizagi built-in validator to track all the required input attributes. For example, if I remove first name parameter and try to run connector, the built-in Bizagi validation utility will throw clear and descriptive error, including what exact parameter is missing. This is very simple to implement and requires only few lines of the code. Next comes input data transformation. This is relevant when data structure coming from the process does not match with external API. For example, in this case, the API requires first name and last name to be sent as a single combined attribute. After transforming data, I will format JSON object into the string, since HTTPS module works only with strings. Before continuing, let's talk about why using built-in Node.js HTTPS module. First, you don't need to install any additional libraries. It's native and already included with Node.js. Second, you have full control over how the request is built and how the response is handled. Another important aspect is security. Every third-party dependency introduces potential vulnerabilities and requires continuous maintenance to stay up to date. Additionally, less dependencies means smaller connector package size. In practice, this means faster startup time when the connector is executed for the first time. Because Bizagi needs to unpack and cache the connector package before execution, so smaller package leads to faster and more reliable startup. Of course, there are some drawbacks. if compared to Axios or similar libraries. First, code is more complex, and you need to manually implement some specific features like retries, interceptors, or advanced error handling, because these features are already built into the Axios package. Now let's start implementation step by step. First, we define HTTPS options object, which includes hostname without HTTPS at the beginning. Port usually is 443. Path will specify the specific API, HTTP method, and headers. In the headers, I always recommend passing case number. This is extremely useful when tracing API calls back to specific Bizagi case. You can also include other headers like API key, authorization token. The last important option is timeout. This defines how long connector action is allowed to execute. If you are using service task, make sure that service task timeout is longer than the connector timeout. Otherwise, service task might fail before connector finishes execution. Next, let's create request object using previously defined options. We then add separate logic for general request errors and timeout handling. This is important so you can clearly distinguish between a timeout and other type of failures. When the timeout is reached, we explicitly call destroy method on the request. This stops the request and triggers error event. By checking the error code, we can identify why request failed. Was it due to timeout or any other error? And finally, we write pull request body and end request to initiated API call. Now let's look how to handle a response. First, we set proper encoding and define placeholder variable to accumulate response data, which will arrive in chunks. Once all data are received, the end event is triggered. At this point, we evaluate HTTPS status code. Typically, 200 status code will indicate that you got successful response, while anything else is treated as error. But of course, you should adjust this logic based on your API specification. This is also a good place to perform transformations of the response and mapping, ensuring that API response matches with the connector output structure. In this example, I have added additional text attribute which will be merged with the original response. To test this implementation, we need mocked API. For this demo, I'm using Bceptor, which is a great free service for mocking APIs. I've created a simple post endpoint that will simulate user creation, and I have added artificial delay of 10 seconds to simulate slow API response. Let's run the connector. And after 10 seconds, we have received full response from mocked API, including the additional attribute which we added directly in the connector code. Now let's test timeout behavior. I will reduce system configuration timeout from 30 seconds to 5 seconds. And after 5 seconds, the timeout will be triggered and the request will be stopped or destroyed, which will then trigger the error event. In the error handler, we will detect if the specific error was due to timeout, and if yes, then return specific error response, which will be then handled in the Bizagi process. As you can see, after 5 seconds, we received a detailed timeout error message. Finally, let's simulate API error with some 500 response code. Here we can see when we run the connector again, we got error, which was captured with relevant error status code and returned detailed error message. That's it for this video. Thank you for watching, and I will see you in the next one. So thank you for watching. If you found this video useful, please subscribe, hit the like button, and let me know in the comments what other topics I should cover next.